Let's look at an example describing linear and angular speeds and how they're the same and how they're different. So here's our setup. We have a pottery wheel and a diameter of 24 inches, and it spins at a rate of 30 RPMs, which stands for revolutions per minute. Some people say rotations per minute. So the diameter is 24 inches, and the speed that it's spinning around is 30 RPMs. So, I don't know, let's just say it's spinning counterclockwise. So that means that it spins all the way around 30 times within 1 minute's time. So first I'd like to find the angular speed in radians per second. Angular speed. So we're thinking about the angle that this is making and per unit of time. And so the key is, what are the units they want? They want radians and seconds. So let's write down what we start with. We have 30 revolutions per 1 minute, divided by 1 minute. Now I want to multiply this by forms of 1. So let's start with the conversion to radians. So I want to get rid of revolutions. That's going to go in the bottom here. How do I get rid of a revolution? Well, we overthrow the dictator? No, that's not it. 1 revolution is equal to how many radians? So 1 revolution, that's 1 time all the way around. Well, we just learned about that. That's 2 pi radians, or 360 degrees. So if the angular speed is in degrees, our conversion is 360 degrees over 1 revolution. This is in radians, so we're doing 2 pi. So now I'm multiplying by a form of 1, so that's not changing the value of my expression. It's just putting it in a different form. So my revolutions cancel, and the next thing I want to do is I want to have seconds, so I need to get rid of minutes. Now minutes are on the bottom, down here, so I'm going to need to have minutes on the top, so those minute units will cancel, and I want to convert it to seconds. Well, what's the conversion for minutes and seconds? 1 minute is 60 seconds. So now my minute units are gone, and I'm left with radians per second, and that's what we were supposed to have. And so now it's just a matter of simplifying our expression and combining everything. And so what do we have? In the numerator we have 30 times 2 pi times 1, so that's 60 pi. In the bottom, 1 times 1 times 60 is 60. So 60 pi over 60 simplifies just to pi, and my units are radians per second. So a little bit over 3 radians per second, and we know that pi represents 180 degrees. So it's 180 degrees per second, or a half of a turn, half of a rotation per second. Now we could have thought through that without doing this dimensional analysis. I know that some of you might look at that and say, well, that's just simple. If it goes around 30 times in 1 minute, that means that it's going to go half a time around every second, and I'm done. There's my answer. But there's going to be problems you won't be able to actually just look at it, and it'll be that easy. So understanding the dimensional analysis is important. Let's try to get another part of this problem, referring to the linear speed. So find the linear speed. So if we go back to our wheel, and think of this like a bicycle wheel or a car wheel, and if it's rolling, just keep going, and it's rolling down the street, if it was going in a straight line, we could actually measure the length of the distance it's gone over a unit of time. And that length is really representing the circumference of our circle. So when we've gone 1 full revolution, if we had spray painted the wheel and said go, and we started to roll until it went all the way around exactly once, we would make a line from that spray paint on the ground, and that represents the distance we've gone, which is the circumference of the circle. So that's the idea behind this linear speed. How far has it traveled, or how much of the circumference has been covered per unit of time? Now the setup is exactly the same idea. We have 30 revolutions per 1 minute. Now they didn't tell us any units on this, but for linear speed, we know that it must be in something like feet or meters or centimeters or inches or yards or miles. And in the original problem, we know that the diameter was equal to 24 inches. So I'm going to convert to inches for now. And if I want to, I can change that later. So I need to get rid of revolution, so I'll put that in the bottom. And I want to convert it to inches. Now, what's the conversion factor? One revolution, or one time around this circle, well, that's the circumference. And circumference is diameter times pi. And the diameter is 24. So there's 24 pi inches in one revolution for this particular wheel. And so now I've gotten rid of the units revolutions. Now, where am I at with this? So right now that would be 30 times 24, 60, 72, 720 pi inches per minute. Now pi is a little more than 3, so we're talking, over 2,000 inches per minute. That doesn't seem to be a realistic way of expressing the linear speed, because that's so many inches. So maybe we need to convert it to either seconds, or we can convert it to feet. And in most problems, they will specifically tell you what units to put it in. But let's say we wanted to convert this to feet. So that would mean getting rid of inches, and since inches is in the numerator, I'm going to put my inches in the denominator, and we'll convert to feet. What's the conversion? 1 foot is equal to 12 inches. And so now my inches will cancel. And so basically I'm dividing by 12. So now my answer would be 60 pi feet per minute. And even that's what, about 180, 190 feet per minute, 60 pi. 188 and a half feet per minute. That still seems not like a number that we would express in terms of our linear speed. So we could keep going if we like. And let's say we wanted, and the reason I'm just going through all these different possibilities is to show you how you can convert and change your units pretty easily. So what do I have right now? Right now I have feet and I have minutes. And I still have a pretty big number, 60 pi, 188 and a half. So what if I cut my minutes down and did it in seconds? What would that do? Well, if I want to get rid of minutes, those would go on top. And convert to seconds, those would go on the bottom. What's the relationship? 1 minute is equal to 60 seconds. So now my minute units are gone, and now my answer is in feet per second. And so I would have to divide that by 60. And so we have, and just to make sure, keep track of the numbers we're looking at. We have 30 times 24 pi times 1 times 1. On the bottom we have 1 times 1 times 12 times 60. And so we multiply the top, multiply the bottom, and then divide. And what are we going to wind up with? Well, we wind up with exactly pi. And my units are feet per second. And that probably seems like the most practical answer to go with, or about 3.14 feet per second. And that's how fast that wheel is moving around in terms of its linear speed.